benzoic acid, being a carboxylic acid, is actually acidic. Let's draw the structure of benzoic acid, and then we'll try to see the effects of groups or substituents, if you like, on the acidity of benzoic acid. So this is benzoic acid. It's a carboxylic acid. It's therefore acidic. The pKa of benzoic acid is about 4.2. It's slightly less the pKa of benzoic acid than that of normal carboxylic acid. That's because of the further delocalization of electrons in this carboxylic acid, which results in a slightly more acidity or higher acidity than non-aromatic, if you like, benzoic acids. Let's now try to see the effects of groups on the acidity of benzoic acid. So if there is a group on benzoic acid, what effect would it have on the acidity? And of course, as we have seen before, that groups can either be electron-donating groups or electron-withdrawing groups. So if there is a benzoic acid like this, substituted in general with an electron-donating group, and we mean in this regard, in general, an electron-donating group by resonance. So if there is an electron-donating group by resonance, there will be resonance donation or donation of electrons by resonance on this way, if you like, which would result in localization of electrons on the carboxylate. We will see this shortly on due course, actually. So the EDG would donate electrons to the benzene ring. Now, this substituted benzoic acid with an electron-donating group would be less acidic, therefore, because of the donation of electrons. So the pKa here in general should be greater than 4.2, and therefore these carboxylic acids would be less acidic. And of course, when we say less acidic, we mean in comparison with unsubstituted benzoic acid itself. So that's one, if you like, one extreme of a substituted benzoic acid with an electron-donating group. If we have another case where the benzoic acid is substituted with an now electron-withdrawing group, and again, in general, we mean an electron-withdrawing group by resonance. Of course, it could this be applied to electron-withdrawing groups by inductive effect as well. Electron-withdrawing groups by resonance or by inductive effect withdraw electrons in the carboxylate, and this results in delocalization of electrons and therefore stabilizing the conjugate base. So these benzoic acids, which are substituted with electron-withdrawing groups, are actually more acidic than benzoic acid itself. The pKa should therefore be less than 4.2, which is the pKa value for unsubstituted benzoic acid. So these benzoic acid, again, which are substituted with electron-withdrawing groups, are actually more acidic than benzoic acid itself. So in summary of this, electron-donating groups on benzoic acid lower the acidity of the benzoic acid. Electron-withdrawing groups on the benzoic acid actually enhance the acidity of the corresponding carboxylic acid.